to our bearing number code video. In today's video, we're diving deep into the world of bearing number codes, a crucial aspect of understanding bearing specifications. Additionally, we'll explore different bearing number code standards, primarily focusing on the JIS standards and the ISO standards for metric series bearings. Let's start with a typical metric bearing number code and break it down. The first number on the bearing indicates the bearing type. In this example, the number 6 represents a deep groove ball bearing. The second digit reveals the diameter series, with the number 2 suggesting a light series with a particular cross-sectional width. The third value on the bearing represents the nominal bore diameter, and as shown here, we have the value of 5, which equates to a bore size of 25 mm. Moving on, the fourth element of the code addresses the shielding type of the bearing. For instance, ZZ in this case indicates a double-sided steel shield. Subsequently, codes like C3 detail the internal clearance of the bearing, with C3 symbolizing a clearance larger than the standard bearing clearance, ideal for high-temperature operations or ensuring minimized noise and vibration. But that's not all. Some bearings also feature an additional lubrication code. 2AS, for instance, tells us that the bearing has been lubricated with Albania grease S2. This was only a quick glimpse of the bearing number codes, and will provide a detailed breakdown of each code for a more comprehensive understanding. So stick around as we unpack the significance of each code and the popular bearing number code standard. As an engineer or engineering enthusiast, you might have encountered bearing number codes and wondered why they come in different formats. This is because bearings come in many different types, sizes, and specifications to suit various applications. This leads to a vast array of bearing number codes to precisely identify each bearing's characteristics. Furthermore, each manufacturer typically has its own bearing numbering system or code format, which can make it challenging to cross-reference bearings from different manufacturers. While there are internationally recognized standards for bearing numbering, manufacturers may also have their own proprietary numbering systems that include additional information or special features not covered by the standard numbering systems. To enhance your understanding of bearing number code formats, let's begin with a selection of examples. Focusing on the first bearing number code example here, we have a code format similar to what we showed earlier in the video. As you can see, the ball bearing type number comes first, followed by the diameter series and then the nominal bore diameter. Also, there's an extra element for the contact angle, the letter B, which refers to a contact angle of 40 degrees. The duplex arrangement code is next. Additionally, the first element of the second section of the code indicates the preload condition. For example, the letters GM suggest that a medium preload was applied to the bearing during its installation. The very last element indicates the bearing tolerance class. In another example, the format seems almost reversed compared to the two examples mentioned earlier, with 3 letters before the /. These first 3 letters indicate the bearing type, width series, and diameter series. However, in the second section of the bearing number code, there is a dedicated code for the cage material and construction, with the letter B indicating a machined cage. Let's also examine another bearing code number with a different format. In this example, there are 2 values at the beginning of the code, separated by a hyphen to provide information about the special application and material or heat treatment of the bearing. The code 4T refers to the type of case carburized steel used to make the bearing and its components. This is followed by the main bearing basics number, such as the bearing type and diameter series, and so forth. As you can see, the bearing code number can come in various formats, which might be confusing for some. However, we will show you that all the examples explained earlier follow a common standard numbering system. By explaining the details of the numbering system, we hope to provide a clear picture of how bearing number codes are formatted. In this segment of the video, we will clarify how the 3 different bearing number codes we have discussed earlier are interconnected and fall under the comprehensive bearing composition and arrangement table. The table breaks down the bearing number codes into 3 main sections. Firstly, the supplementary prefix code section. Secondly, the basics numbers section. And lastly, the supplementary suffix code section. Please note that the bearing numbering code system we discuss here was developed by the NTN Corporation, one of the most prominent bearing manufacturers in Japan, and is primarily aligned with the standard formats instituted by the International Organization for Standardization, or ISO, and the Japanese Industrial Standards, or JIS. As you will recall, the examples we discussed earlier contain elements from each of these sections. For instance, the supplementary prefix code includes information about special applications, materials, or material heat treatment codes. This was evident in the third example, where the element 4T falls under the supplementary prefix code. Moving on to the basic numbers section, which is present in all our examples, typically includes the bearing type, dimensional series, bore diameter, and contact angle codes. For instance, the codes 7, 2, and 3 in examples 1 through 3 indicate the bearing series code. Next, the width series of the bearing, part of the dimension series code, is indicated by the numbers 4 and 0 in examples 2 and 3, respectively. The diameter series code is also part of the dimension series code. For example, the diameter series code is 0 in both the first and second examples, and 2 in the last example. Moreover, the codes 12, 750, and 8 in examples 1 through 3, respectively specify the bore diameter of the bearing. Additionally, the letter B in the first example represents the contact angle code. Lastly, the supplementary suffix code includes additional details such as internal modification, cage type, seal shield, raceway external configuration, duplex arrangement, internal clearance preload, tolerance, and lubrication codes, as exemplified in our previous discussions. This was illustrated by the letters GM and P6 in the first example, and the codes B and K30 in the second example. By explaining these common standards, we hope we have provided a clear picture of how bearing number codes are formatted. Now, let's explore more examples for each section of the bearing numbering code table. For the supplementary prefix, code E represents bearings made of case-hardened steel, while F denotes stainless steel bearings. Additionally, the codes TS2, TS3, and TS4 are used for dimension-stabilized bearings designed for high-temperature applications with maximum tolerances of 160, 200, and 250 degrees Celsius, respectively. For the bearing series code, let's look at the code values and which bearing types they represent. We start with code 1 for self-aligning bearings, followed by code 2 for spherical roller bearings. Next, we have code 3 for tapered roller bearings and double row angular contact bearings, and then code 4 for double row ball bearings. Code 5 is for single direction thrust ball bearings, and as previously mentioned, code 6 represents single row deep groove ball bearings. We continue with code 7 for single row angular contact bearings, and code 8 for cylindrical roller thrust bearings. At this point, the numbering code transitions from digits to letters, starting with the code N for cylindrical roller bearings. If the cylindrical roller bearing differs from its standard configuration, the letter N is followed by a second or third letter. For instance, code NN represents double row roller bearings, and NA indicates needle roller bearings. The width or height series and diameter series provide information about the bearing's dimensions. The width or height series code consists of a single digit representing the relative cross-sectional size or height of the bearing to its diameter. This series progresses in the order of 8, 0, 1, 2, 3, 4, 5, 6, with code 8 denoting the thinnest section of bearings, which are typically used in applications where space is extremely limited. On the other hand, code 0 represents the standard series of bearings that are used for general purposes. As the codes progress from 1 to 6, the bearing width increases, making these bearings progressively more suitable for applications requiring higher load carrying capacity. Continuing on to the diameter series code, it progresses in the sequence of 7, 8, 9, 0, 1, 2, 3, and 4. For instance, the 0 series encompasses bearings with standard dimensions, while the 8 series comprises extremely thin section bearings. Meanwhile, the series from 1 to 4 indicate progressively larger cross-sectional heights and outside diameters. The unconventional numbering of the series codes might raise questions for some. This inconsistency is due to historical and practical factors. Initially, manufacturing limitations only allowed for bearings with lesser load carrying capacities. As technology and manufacturing capabilities evolved, bearings with thicker sections and higher load carrying capacities were developed and integrated into the existing system. Hence, the series codes for them were added to the existing classification system later. The bearing bore diameter code is a 2 or 3 digit number that indicates the bore diameter of the bearing in millimeters. It is important to note that some codes directly convert to the bore size in millimeters while others do not. For instance, for smaller bearings under 10 millimeters, The bore code directly corresponds to the bore diameter in millimeters. For example, a code 1 indicates a bearing with a 1 mm bore diameter. However, the code 00 corresponds to a bore diameter of 10 mm, 01 corresponds to 12 mm, 02 corresponds to 15 mm, and 03 corresponds to 17 mm. Codes 22, 28, and 32 can be directly converted to bore diameters. However, from 04 to 96, the bore diameter in millimeters is calculated by multiplying the code by 5. So 04 corresponds to 20 millimeters, 05 corresponds to 25 millimeters, 06 corresponds to 30 millimeters, and so on up to 96, which corresponds to 480 millimeters. Codes larger than 500 can directly be converted to the bore diameter, with the largest bore diameter being 2,500 millimeters. The contact angle is usually denoted by the symbols A, B, C, or D, which are included in the bearing number to indicate different contact angles. For example, letter A represents a contact angle of 30 degrees, B signifies a contact angle of 40 degrees, C indicates a contact angle of 15 degrees, and D represents a contact angle of 25 degrees. The contact angle of tapered roller bearings differs from other types of bearings due to their angled rollers, and it is defined within specific ranges as shown here. The supplementary suffix code provides additional information about the bearing. For example, the internal modification code could be ST, which indicates low torque tapered roller bearing design. The cage type might be represented by M, signifying a high strength machined brass cage. The seal shield code could be LH, indicating one side synthetic rubber seal. More examples of the seal shield codes can be found in the table provided. The raceway external configuration might be represented by letter K, denoting a tapered inner ring bore. The duplex arrangement could be DF, indicating face-to-face arrangement. The internal clearance preload might be GH, denoting a heavy preload on the bearing. The tolerance could be P2, indicating that the bearing is manufactured to a very high level of precision. And the lubrication code might be LP03, denoting that the bearing is lubricated with solid grease. Please note the classification and features associated with each number can vary slightly between different manufacturers and standards organizations. Therefore, it is always recommended to refer to the specific manufacturer's catalog or the relevant standard for the most accurate information. We covered many details regarding metric bearing number code standards in this video. However, in our upcoming video, we plan to explore the details of the inch series bearing number code standards and compare them to the metric series code standard. If you enjoyed our content, please make sure to like and subscribe to our channel. Goodbye.